Hi, everyone. Thanks for coming to my talk. Thanks to the organizers for having me, and thanks for giving me the first slot. Totally no pressure. Hello, hello. Whoa, what? Yeah, sorry. Yeah, I should let go of the button. Yeah, so the topic for this session is going to be running Rust on Android. I will talk about how a few years ago I had the opportunity to work on a mobile app that was partially written in Rust. And well, I will walk you through the whole adventure of getting getting this thing working, along with some dead ends along the way. Right. So a brief look at the agenda for this talk. So I will start with just a few words about who I am. I'm gonna give you some of my background. Then I'm gonna paint the background for this whole story. I will give some short introduction into the Android SDK and NDK, so basically the building tools. I will talk then about cross-compiling Rust code with some detour for building external libraries. I will talk about what it took to get a useful APK, and then we're gonna go into a journey into JNI land. All right, so who am I? So I've been working with software in various capabilities for some 22 years now. Geez, time goes fast. Yeah, I've been working as a developer for about 12 years out of that, and writing Rust for a living for about 3 years. I'm also a package maintainer in Fedora Linux, where I maintain various different packages, mostly just some CLI tools, but also stuff like games. I'm also doing some sports, mostly running. And I'm also a blood donor, and you should do it too. I very much encourage everyone to try it. All right, so how I got into this mess. So back in 2021, I had the opportunity to work for a shiny, brand new startup in the cryptocurrency space. Well, but the thing is, we weren't trying to make our own coin. We actually wanted to utilize multi-signature algorithms to build a more secure wallet app. So basically, if you've never had anything to do with cryptocurrency, then you're not really at that much of an advantage. I don't know a lot myself either. But basically, when it comes to crypto, you have your traditional dilemma, whether to use like a personal wallet or an exchange. So with a personal wallet, the advantage is that the money is truly yours. But the problem is that, well, you need to be very careful about the private key to your wallet, because, well, if you lose the key, then you lose access to your money. And if you leak the key somehow, then, well, someone else has access to your money and can just yank it. On the other hand, if you're gonna use an exchange, well, there's less risk of losing access to your money. But on the other hand, there have been plenty of stories about exchanges getting hacked and, well, the money being stolen. And there was actually like 1 or 2 stories about exchanges that turned out to be scams, as in they ran for like a year or 2, and then the founders just took all the money and ran away. Yeah, and like another thing that I didn't put on the slide, but now that I think of it, like if you're using crypto, then it's very likely that you're also very much into privacy. So another con of exchanges is that in some countries, exchanges are actually bound by law to do the know your customer process. So they actually do need to like take your data and confirm that you are who you claim to be. Yeah, so like I said, our idea was to utilize multi-signature algorithms, and the well, to put it shortly, the idea behind multi-signature algorithms is that the private key is split into several shares. And the great thing is that you do not need all the shares to sign a transaction. So you can, for example, go for a free 5 scheme, where the key is split into 5 shares, but you only need 3 shares to sign a transaction. And, well, this has some obvious advantages. So on one hand, if you lose one of the shares, then you still have access to your money. And on the other hand, if someone else, hacks one of your devices or steals one of your devices, then as long as they have only one share, or even if they have two shares, in a 3-5 scheme, they will need 3 shares in order to actually access your money. Just a brief note, because this picture might actually give you a bit of a wrong idea. The way this works is not that you generate a key up front and then you split it. It is actually possible for these 5 devices to generate a key in a distributed manner. So at no point in this process does any of the devices actually have the entire key in memory. So like there isn't any point in time where you can potentially exfiltrate the whole key just by compromising a single device. But as you might expect, all of this is backed by some complicated maths, and the Rust ecosystem is very diverse when it comes to publicly available crates. Instead of just implementing all the algorithms from scratch, we just took some public crates and modified them to work over the internet. So basically, we had a crate that would go over the that would create all the shares on a single thread. Just basically allocate an array of 5 shares, and then just go over them in a loop sequentially. I don't know if this is my laptop's problem, but we have no slides. All right. So basically we started with that. We modified it so it would use 5 threads in a single program to create those 5 shares. Then we modified it so you would need to launch the same program 5 times on one device, and they would talk using just local HTTP or maybe Unix sockets. And then the next thing, we modified that so you could actually have 5 copies of the program running on different devices. You would give them some session token, and they would connect to our servers. And as part of that session, they could generate the key, and they could sign transactions. But having a CLI program that does the job, it didn't really help us much. Because, we were a brand new startup. We didn't really have all that much money. So we needed some way to attract customers and perhaps even more importantly, attract investors. And, having a CLI app is developers may want to use it, but normal people won't really be interested. So we needed some easy to use GUI app. And after some debate, we decided to go mobile first. The main motivation behind going mobile first was basically that it will be the lowest barrier to entry, and it will allow us to potentially get the most users in the shortest amount of time. Like I mentioned, I am a packager for the Fedora Linux distribution. Over the years, I've also worked a bit with packaging for other Linux distros. I've also dabbled with cross-compilation because, for example, if you were to go to my personal website, you'll find some games, and all the Windows builds, they're actually cross-compiled from Linux. I don't build the Windows builds on Windows. So basically, I thought to myself, I do have some experience, so why not? Let's volunteer. After all, how bad could it be? Right, so typically when you want to develop software for a platform, you need some kind of SDK, a software development kit, and Android is no different in this regard, except it comes with 2 such kits. So the first part of the SDK is the SDK. It contains Android's Java and Kotlin APIs, as well as various tools needed to lint, build, sign, and debug Android apps. The second part is the NDK, or the Native Development Kit. It contains the C, C++ compiler and linker, relevant native libraries, and so on. Basically, it contains all the stuff that you don't really need when you develop pure JVM apps, yeah, whether that be Java or Kotlin or whatever. You can download the SDK and NDK for free from the internet, from Google's websites. Once you download and install them, you just need to set up some environment variables. So that's like Android _ SDK _ root. Although I should note that this one is actually deprecated. Nowadays, you're supposed to use Android _ home, but like none of the tools I've tried didn't still support this one, so it's still good. And also the same thing for NDK, so Android _ NDK _ root. All right, so once you have the SDK and the NDK ready, you can try cross-compiling Rust code. So while the NDK contains many tools, like I mentioned, the C compiler, linker, debugger, it doesn't contain the Rust compiler. Ah, bastards. But this is something that can be easily solved if you're using Rustup. You just type Rustup target add, and then you specify the targets. So AArch64, that will cover the ARM64 devices. ARMv7, that will cover 32-bit ARM devices. x86-64 is mostly useful in terms of running your app in the Android emulator, which is part of the SDK. In terms of hardware, historically, there were some tablets based on x86-64 that were running Android. And there are also some masochists, I mean hobbyists, running Android x86 on the devices. But like I said, this will be mostly useful in terms of testing the app locally on the Android emulator. All right, all good. So we can try compiling. If you're using cargo build, then you can just use the -- target option to tell it that you want to compile for 64-bit ARM Android. Yeah, so I did just that, and oh no, it failed. So after taking a brief look at this, I noticed, all right, here it says USR bin LD, so that's the system linker, and file in wrong format. So yeah, like that makes sense. Like the cargo is probably still trying to use the system linker, even though I'm building for Android. So maybe just setting up some environment variables will help. All right, so Android NDK root. This thing toolchain is just for me to avoid having to type all of this again. All right, so I'm going to tell it the C compiler to use and the linker to use, and well, that didn't work. So at this point, I thought to myself, well, okay, but I'm kind of like taking wild guesses here. Like, surely someone else has tried it before, and surely this is a solved problem. And what do you know? Cargo APK helps Cargo build APK. Wonderful. You just need to add some extra configuration to your Cargo toml, and then it works. All right, fantastic. Let's try that. Cargo install Cargo APK, yeah, set up the SDK root, the NDK root, and then just run Cargo APK build. And yeah, that failed again. But what this time? Cannot find LSQLite 3. All right, that's a thing. Yeah, so as much as we were ardent believers in the rewrite it in Rust movement, our project still used some C libraries, which meant that I had to get those out of the way too. Fortunately, the NDK docs contain some examples showing how to build C projects. Obviously, what you need to do to build a C project depends on the build system used by the C project, because as we know, there are like 20 different build systems for C, and each of them is broken in a different way. This example is for projects that use auto tools, because SQLite uses auto tools. I mean, there were also some other libraries in our project that we needed to solve, but like I'm not gonna talk about all of them because that's not really relevant. Yeah, so like I said, so for C projects using auto tools, this is about the setup you need. So yeah, C compiler, C++ compiler, linker, whatever. And after that, it's a pretty standard thing. Configure host. Once again, tell it that you want ARM64 Android. Make, and it runs. All right, so building the C library worked, but I still needed to figure out how to allow the linker to find the library, and eventually I just solved this in the most the most simple way possible, which is just by passing some Rust flags to tell the linker where to look for the library. Yeah, so that was a partial success, because the linker was happy, but Cargo APK wasn't happy because it told me shared library SQLite was not found. All right. So what now? Well, at this point, I went back to the build logs and just took a very good look at the linker output, and I noticed, when Cargo builds stuff, it puts pretty much everything in the deps directory, and the linker also seems to look for libraries inside the deps directory. So what if I just smuggle this into the target Android debug deps directory? So yeah, I did just that, and would you look at that, it worked. The linker was happy, Cargo APK was happy, and I actually had an APK that I could install on my device. It didn't do anything; it would just like show a black screen. But hey, you could install it. Wonderful. Yeah. So while I was busy wrestling with cross compilation, my colleagues made a mobile app using React Native. You might be wondering why React Native. Like I said, small startup. There were literally like 4 of us. So we were trying to save on engineering effort at every possible moment. And well, using React Native had the advantage that we could target Android and iOS with the same code base. And it also meant that we could do most of the development just in the browser. We didn't really have to build the app and upload it to a mobile device every single time. Yeah, so we had a mobile app using React Native, and I had the Rust code in a separate app. And well, now I had to figure out how to combine the two. So in my naivete, I typed how to combine APK into the search engine. And as it turned out, you can't really do that. That's not how it works. All right, so in which case, if that's not how it works, then how does it work? So the thing is, the fundamental building blocks of Android apps are activities. And no, I'm not going to read all of that to you. Like, if you're interested, then you can just like go to the Android developer documentation and read it yourself. But basically, the gist is, like, if you think of a web application, then a web application will typically be split into like several different pages. Yeah. So for example, like if you have like a webmail client, then you will have like a separate page for browsing the emails. You will have a separate page for like reading an email, a separate page for composing an email, maybe a separate page for going through your contact book. And this is kind of a similar idea. So like it is totally possible, it is totally legal to create an Android app that contains only one activity and everything happens within this single activity. But basically, you're encouraged to split your app into several activities. And that may make development a little bit more difficult, but it makes cross-app collaboration easier. So like, for example, like if you take your phone and you have, and you like take a photo and then you press share and you have like different messaging apps proposing you that, hey, you can share the photo using me, your favorite messaging app. If you use that share option, then what will happen is that you will most likely you will send this picture like straight to the compose a message activity within that messaging application, which makes the whole system, like I said, more modular and whatnot. All right, but going back to the topic, the good thing about activities is that they can launch one another. And launching is done through a system called intent. And the intents can hold various pieces of data. So like the most basic stuff is the action. So you can specify stuff like action view, action edit, action main. You can pass on some extra data using through like a URI. But you also have some different options, like for example, you can specify a MIME type, and there's even this extras thingy which pretty much just serves as a key value store, as a dictionary. So basically, using the intent thingy, you can pretty much just pass any data along that you want. Right. So what Cargo APK did was it would compile our Rust code and it would wrap it in a native activity. And this actually opened a possibility for me. So I couldn't like just take the APKs and combine them together. But what I could do is I could take the two activities and put them in a single APK. And then I could potentially have the GUI activity invoke the Rust activity. All right, so the first step was to get my native activity code. And for this, I would once again engage in some file smuggling. So if you look at the directory structure of a Gradle project, Gradle being the build system for Android apps, you're going to notice this folder, JNI libs, and which then has subdirectories for every architecture. And basically, whatever you put in these directories, Gradle, the build system, will pick up and it will put into the final app. Just no questions asked. Right, great. The second step was to just take my native activities description from the Android manifest XML file that was auto-generated by Cargo APK. If I go back a couple of slides, you can notice it here. Yeah, that it auto-generated a manifest file. So I could just take the definition of my native activity and just copy paste it to the other app's manifest. So I did that. The build was successful, and oh no, I got two launcher entries even though I installed just one app. What happened? So like if you look at the description of the activity, then maybe it would be useful to delete the launcher category. So I did just that, and now I had one app that installed a single icon in the launcher. Great success. But there was still one problem. All right, so now I have two activities inside one application. And these activities, they can potentially talk to each other, but this whole system, of one activity invoking another is done, and the intents, like that all happens on the Java side, and I'm in native code. Like, how can I access the data that's in those intents and whatnot? I looked at the tools that came with Cargo APK, and I didn't really find like any wrappers that would make this easily accessible, which meant that unfortunately it was time for me to venture into JNI land. All right, so JNI is the Java native interface. So basically, if you've ever had to interface between different programming languages, then, well, you know, the foreign function interface, FFI stuff. Yeah, and so JNI, the Java native interface, is basically just that, yeah, a way to do FFI in Java. And yeah, so as I started reading on JNI, I realized that it had one advantage, is that I could leave all that native activity and intent stuff behind and just stick my code into some static functions. Which means that, yeah, you've just spent 10 minutes listening to me talking about stuff that eventually turned out to be completely useless, but hey, I hope it was a learning experience. All right, so we can start with the simplest possible case. So just a like the most basic static function in Java that takes no arguments and returns nothing. The Java compiler comes with an option that you can use to generate JNI function headers. So that's javac -h. The first argument is the directory where you wanted to put those auto-generated headers, and then you just point it to the Java code that you're interested in. And once you do that, you will get something like this. Well, obviously, the full generated file is a bit more complicated because you have stuff like include guards, but like the interesting thing is this. Yeah, you have like include JNIH, and then you have basically just a void function that has this very fancy name. Like if I go slide back, you will notice that this actually matches the full name of this function. Yeah, so I'm in a package com startup hip. I have a Rust code. I have a class called Rust code and a function called dostuff. So yeah, there's the prefix Java. Then there's my package name com startup hip. There's Rust code, which is the name of the class, and then there's dostuff, which is finally the name of the method. And as you can see, it takes a pointer to JNI-env and a J class. Yeah, so, well, that's fairly simple. We can convert this to Rust, no problems. Yeah, remember about this bit, no mangle, because Rust has name mangling, and in this case, this function, like, it has to have this specific name, so we don't want name mangling. Yeah, and the other thing to remember about is that starting with Rust 2024, we have unsafe attributes, and no mangle is an unsafe attribute. So if you are ahead of the curve and you're using Rust 2024, this will be slightly more involved. All right, how about taking some arguments? Yeah, so not that much complicated. Just yeah. Just declare an argument in the Java code, and I'm not going to show the C headers anymore, but translated to Rust, it just appears as another argument to our native function. So for primitives are pretty much handled as you would expect. So if you do like an int, then it will also appear here as an int. Strings are a bit more involved because you get them as a special Java class. And well, Java strings are a bit special and they require some extra handling. Does anyone want to guess why Java strings are special? They are not UTF-8. No, they're not UTF-16. Well, that's not really relevant. Like I'm talking like about the way the string, like the byte buffer looks. No. So they're not UTF-8. They're not UTF-16. They're also not UCS2. What are they? They are a special modified variant of UTF-8 that only Java uses. Yeah, so to convert from a Java string to a Rust string, you just need some extra boilerplate code. Yeah, you may be worried about this unwrap here. This will panic only if the string was null. yeah, because like one member in the audience mentioned, Java strings are classes, so it is possible to have a null string. But well, if you don't really care about that, then you can just slap an unwrap, whatever. Right, great. What about returning a value? So once again, just add your return type in the Java code, and it just appears as a return type from the native function. Wonderful. Yeah, creating a Java string from Rust code, well, it also requires some conversion. So you will also have the JNI-env new string from your string, and well, once again, there's an unwrap here. This will pretty much only error if you run into an out of memory issue, in which case, well, you're pretty much screwed anyway. So once again, I decided that I don't really care much about the unwrap. Yeah, so I wrote this bit of code where I would just call a Rust function, and then depending on the result, I would create a string that would either start with an OK or it would start with an and well, I returned that from my JNI wrapper, but I was writing Rust. We use result TE everywhere. It's like the thing that it's like the thing. Like if you ask people what do you know about Rust? Oh, they use results everywhere. So could I have and I really wanted to have a similar API for the JNI functions. So could I have that? Well, yeah, I could. So the first step was to create an appropriate Java class. And if you look at this bit here, you'll notice that it just takes a single Boolean that tells is it okay, and then a single string value. So basically, in our case, I took a good look at our Rust functions, and I realized that pretty much all of the values that we return, they are either just byte buffers or they are stuff like session tokens. So we can probably just coerce all of them to strings. And as for errors, once again, we didn't really have that many errors where it would make sense for us to try to react to those errors. It would be perfectly fine if we just took the error message and would just show it to the user in the mobile app, which meant that it was probably also fine to just not return a specific error type and just return an error message, which meant that, well, result TE became result string. So hey, so that's how I ended up with this Java class. Well, obviously you could improve some things here. For example, you might want to throw an exception from the getter functions instead of just returning null. But well, that's a problem for tomorrow. All right, but how can you actually create this object of the Java class from your Rust code? Well, you can do it using the appropriately named newObject function. And well, it takes a couple of arguments. So the first argument is a pointer to the JNI-env, which well, if you look at the signature of the Rust functions, well, the pointer to the JNI-env is the first thing we get as an argument to the functions, so we can just pass that along. I'm gonna jump to the end right now. Then at the end you have the list of arguments. So this will be Java values that will be then passed to the Java function you're calling. So once again, that's pretty obvious in what it does. All right, and then you have the middle two arguments, the class and the method ID. How do we get those two? So the first one, there's another similarly appropriately named function, find class, and you can use it to get a type signature. So you can just so what you do here is you just pass the full name of the class with just one difference, is that instead of dots in the name, you just change them to dashes. So java.lang.string becomes java/lang/string. And as for the method IDs, Sorry. As for the method IDs, the solution I used was to utilize the Java P tool, which is the Java disassembler, which means that yes, I was doing this in a very roundabout way. I was first compiling the Java code into a Java class, and then I was disassembling the class. But hey, if it works, it works. If you look at the output from the Java P tool, you will notice that it shows all the methods, and there is this thing, the descriptor, ZL Java lang string v whatever. Why is this needed? Well, Java supports function overloading, and since it supports function overloading, it also supports constructor overloading. So you can have multiple constructors for your class, which means that, well, when you call new object, you must tell it which constructor to use. And well, that's why that's what the descriptor is for. All right, and with all that, my new object call was complete. So I would find the class, I would construct an array of arguments, and then I would just call env new object and be done. Wonderful. So in the end, our solution consisted of a Java class for returning values, JNI wrappers over the relevant Rust functions, some shell scripts for building the C libraries, even more shell scripts for building Rust code into a shell library as well. Then just copying the libs where the Android build system would pick them up. And we also needed to write a plugin for React Native that allowed for calling the Java wrappers. And if you're interested, because I also mentioned that we had an iOS version. The iOS version was actually a bit simpler because we could just compile stuff into a .h into an archive object and then just link that statically. So we could just use Swift's FFI to call into Rust code, so that was actually simpler, and just another plugin for React Native in Kotlin, I think that was. So if you're interested, if you want to try it out, then you can find an example repo on my GitHub, where you will find basically the whole setup that I've talked about here, and that's pretty much it. Thanks for listening.
Okay, thank you for a great presentation. I really appreciate these small images in your slides. They were really nice. Of course, presentation also was great. Let's proceed with questions. So the way how it works, we will go we start with Slido. If we have some additional time, maybe we'll ask questions from audience. But basically, if you are in audience, you also can use Slido. So basically, there is a priority for Slido, and based on the orders of votes. So Artur, you can see the questions here, but I will also read them. So the first question is about, can you talk a bit more about crypto key sharing algorithm? Did you research it yourself?
No, so we did not research it ourselves. We were not that smart. Like I said, we didn't even implement it ourselves. We just took a ready crate from the I don't remember which crate it was, but it was a public crate that's available on Crates.io. If you want to know how it works, then I'm not sure if that was that was the actual algorithm that was implemented in that crate. But you can go and read the original white paper on Shammy's secret sharing. That's something that's not really new, because the Shammy's secret sharing is something that's from the 70s or maybe even older. There's definitely a lot you can read about if you're interested. But like I said, the long story short is that those algorithms, like they allow you to create the key in a fully distributed manner. So like I said, at no point in time will any of the devices have the full key in memory, which makes exfiltrating the key from a single device not really possible. So yeah, you can generate the key in a distributed manner, and you can sign messages in a distributed manner.
Okay, thank you. So we have 3 more questions. Next is, have you looked into Project Panama and how would it simplify the whole process?
No, I must say I haven't. I don't. I haven't heard of Project Panama. So, but like I said, this was back in 2021. So I don't know if Panama existed back then. Sorry.
Okay, next question. It's from anonymous me, actually. Like it's my question, and actually it changed because of votes. Okay, so it starts with the votes. So what about Cargo NDK? Does it help with the compilation process?
I'm not sure, I must say. I know that Cargo APK does use Cargo NDK underneath, but like I said, I'm not sure because I tried using Cargo APK, like I said, but then when we went the JNI route, we basically just threw all of that away. So we pretty much just ended up using only the JNI crate and not really not using Cargo APK, not using Cargo NDK. Although Cargo APK did turn out useful in that regard, in one sense, is that if I go back a lot, if I go back to this slide when I talked about trying to just set some environment variables and seeing if it worked, I've read through Cargo APK code and noticed that it actually does just that. It sets up some environment variables, and for them it works. Why doesn't it work for us? Well, because they set up different variables. So I just did what they did. I set up the exact same variables, and then using cargo build -- target worked. So at least that was one way when Cargo APK turned out to be useful.
And did you make the liter drawings on slides yourself? They are really neat and actually fits the slides well.
Yes, they are. Yes, these are all handmade, and I'm very not happy that I didn't manage to do them for all the slides.
Okay, and the last question: how do you make sure that the message passed via intent were secure, so no other activities can receive them, or maybe other activity can make some fake message? So how did you solve this?
So in the end, we didn't use the intents, so this was not a problem. But if we were using the intents, then the answer is I have no idea. I'm not an Android developer.
Okay. So that's all the questions. Thank you again for a great presentation.
All right. Thank you.